Another topic that came up in conversation recently was the Diagrid structure. And this is just an example for structural beam elements that are cutting diagonally across the surface. These play out in many different ways. This one is a little bit more radial, whereas this one has a rectilinear outer profile, some of which, of course, can be applied in elevation. But the general idea of the Diagrid is something we can build on pretty easily based on how we've already started. And so what we'll do is we'll walk through a couple of quicker options for this, and maybe a little bit of adding thickness, and then we can follow up on this later if it's a common topic or if some of you are having trouble applying a kind of logic to this to your own work. Let us know, and we can walk you through this using a more particular example. But for now, we'll use this form that we've been working with, and let's get started. All right, so I'm going to try one of the earlier things that we covered, which is to rebuild the surface, and use that wireframe to start connecting the dots. That'll just be one way to kind of at least walk through the basic logic of how you might do something like this using a subdivided surface. So let's just rebuild this. In fact, what I'll do is I'll make a copy. So I always have my original. So let me make a copy over here, type in rebuild, and here I want to kind of just preview the default rebuild, U and V values that they're giving us. I think that's probably a bit too tight for this demo, so I'm just going to drop this down to, like, I don't know, 15 and 25. And yeah, something like this is probably a little more workable. All right. I'm going to make a new layer, make it red, something easy to see. And then I'm going to extract that wireframe. Where is it? There it is. All right. Good. And then I'm going to hide this surface and just go ahead and select all that and type in intersect. In fact, I'm going to fire up a new layer, make that a different color before I run that command, and put my points, my intersection points, on the intersect layer. Okay. And make a new layer and maybe make this one blue or something. And this is going to be our kind of Diagrid center lines. And I'm going to just start connecting these across. Now here you can make them curved or you can make them single line segments. If they're going to be segments, you can just use a polyline command and start connecting across diagonally. Just basically following along where that point, where the next point would be in space, and going along and doing this around until you're finished. And this is going to give you kind of straight segments. So this would be a decent option for something like a space frame where you have a node at every intersection and a straight element in between. But if they are curved and they're longer beam elements that are continuous, the interpolate point curve command is probably a better one, because this will draw a curve along those points. You could even interpolate onto a surface to see if there's any difference there, although I think in this case it would be very similar because of the curvature of the original surface is not too extreme. So anyway, I'm just kind of interpolating curves along this direction here. And of course, you can draw these in the opposite direction. I'll just mirror it quickly just to give you an idea, because this is a symmetrical form. But in any case, you could draw in the opposite direction and start arriving at a Diagrid structure. Okay, so this is one option, at least, to start drawing out and here you can see more clearly the polyline version with straight segments, which if you had to make them separate, you would of course just explode this. And you have individual segments, which can then be added, thickness can then be added, or you've got your continuous sections. Now, to give these thickness would depend on what you're intending to do. So we could sweep these with a cross-section curve all the way across. We could find our normal direction from the original surface from every one of these points using a similar tool that we did before with the form and structure tutorials. And then we can sweep along that. But that's, of course, going to give you a twisted beam, and that depends on, again, if not, whether or not that's possible. But let's talk about adding thickness in a slightly different way. But just before we get there, there's one more method that I think we can walk through, at least to start just drawing out our basic, let's say our basic framework for the Diagrid. Okay, so let's see here. I'm going to copy this over as an option 2. All right, and I'm going to duplicate the edges, so dupe edge here and here. And then I'm going to project these down to the C-plane. Project the C-plane like that, so that they're flat. And I'm going to take these two curves and divide them a certain number of times. Let's just say 25 times. Let's see. Yeah, 25. That's going to be a lot of work, so I'm going to do it instead like a little bit less, just for the sake of this exercise, maybe 15. Yeah, something like that. That's matching what I had over here. Well, close. And then I'm going to hide this because don't need it just yet. We actually don't need these anymore, so we can delete them. And I'm just going to start drawing. I'm going to start connecting the dots basically here. Okay. And okay, and then I'll select my points. I want to get rid of those for now, and then just redivide these a number of times. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yeah, let's just say 12 divisions in this direction, something like that. And then we'll turn on our surface again. Okay. And what we're going to do is we're going to take the points that we just drew here as a new grid that's in 2D and project those directly upward at this surface, which is a different process than what we did here. It means that in this case the spacing is, well, this is an interesting thing. Because we started with an outer profile that's the same as the one above, we're probably going to get the spacing to be pretty similar or the same as how we did it here. This demo works maybe a little bit more clearly if, when you do the projection method, if you have something a lot more freeform up top and something that would be difficult to maintain a kind of constant grid spacing along. But in any case, let's go ahead and project upward onto the object here. So we're just going to do the project command. We're going to select point, SELPT, and then we can just select the surfaces to project onto. I'm going to head to the top view just to make sure it goes in the right direction, hit enter, and now I've got a new grid that's laid out with the exact same spacing that's down below onto my surface, at least in the top view. But the spacing in 3D may now be different. This was one of the methods used on the Smithsonian project. But again, because this has a rectilinear outer profile, and it has this kind of, let me see if I can, yeah, this sort of shape up at the top, this kind of bubble-like form up at the top. There's 3 main bubbles that form these kind of domes that just kind of blend together. Projecting the points directly upward onto that form allowed them to standardize the panel sizes of the glass that was up top to form the cladding. Okay, so that was a method used there. Of course, it was automated, but using some scripting. But it is a similar logic that what we just did. Okay, so just wanted to show another version of this. These points can now be connected in the same way that we just showed by either connecting the dots as polylines, as control point curves, or you can also interpolate on surface. Interpolate curve on surface. Here's the surface that we're going to draw on. And now I can connect the dots however I see fit, and it's going to make sure that the curve that I'm drawing rests exactly along our original surface, if that's something that's important. It may not be important. Exactly, you could use surfaces to make as very, let's say, hard references, or you can also use surfaces just to in an earlier step, just to develop a kind of framework to keep working. So it depends on what you're trying to do. So that's another method, the kind of project up method. And now we'll kind of really quickly just walk through maybe adding some thickness, or using the same method like this, but giving some thickness in between, so we could sweep together our cross sections that way. Okay, let's see. I am going to first make a copy over here, and then I would like to, and now what I would like to do is add an offset to this surface as a way to start developing a process to give us some more accurate thickness. All right, so I'm going to offset the surface. I'm going to use a distance of 10 on my screen. That's fine. As an example, solid, I'm going to click to no and let it run. That's going to give us a new surface that's been drawn with some pretty gnarly iso curves, but we can rebuild that. And paying attention to our U and V count at 15 and 25 in this case, hit OK. And then the surface that was original, we're going to rebuild that to the same U and V count. All right. Now, if we apply the same process that we just went through here, we're going to end up getting a set of offset lines that are similar in logic, but slightly oriented and spaced differently along the two different surfaces. Those two curves can be used just to simply loft them together. So the offset here is a measure of how deep you wanted your structural member to be. And we're using the surfaces as just a way to construct that. Okay, so we can go ahead and do this relatively quickly just by extracting the wireframe for both of these. I'm going to ease up our eyes a little bit by hiding these. I'm going to run the intersect command on both of those. What I should have probably done is put one whole shell on a different layer. That was my mistake, because now I gotta be kind of careful with how I do this. But I think you get the idea. Yeah, actually, I'm gonna go back. That's gonna be really hard to see. So before I extract the wireframe, I want to put this on a different layer, and I'm gonna extract this wireframe on a sub layer so I can keep myself organized. So select that top one, extract the wireframe onto that layer. Okay, so I can turn that off when I'm done. I guess this I should also put on that layer. So I'm going to move that over to layer 9. Okay. And now I can do the same thing here, add a little, add a sub layer, select it. I'm going to make this a different color, and extract the wireframe there. All right, good. I'm going to type in select layer, select that layer 12, run the intersect command, get my points. I'll do the same thing over here. Select layer, layer 10, intersect, got my points. Okay, cool. Now I can just start adding my sections on sublayers as well. Oops, not a sublayer there, but a sublayer here. Make that blue or something like that. Okay, and I can turn the rest of these off just for now and get to work. Gotta keep now. Yeah, I lost my points because I was sloppy. Apologize. But anyway, let's run this one. Oops, wrong command. Got to make sure that the interpolate is on, not the control point curve, because that's going to give you a curve that does not rest along the surface or go through the points. You could do it that way, but you have to keep it consistent regardless. Okay, so there's one section, that layer. That's my top layer. I'm going to do the same thing down here by just hiding this. And I'm going to interpolate down, and I lost my, okay, what are we doing here? There we go. Let's just hide this. Okay, and now I can just control point curve my way through the ones that are related but just below. Alright. And there's your twisted beam. Now again, you gotta know for yourself whether or not that's okay. But again, just to kind of draw out the logic here, and we can loft that together to form our section. If we go ahead and mirror that along somewhere along the center, you get the idea that as you keep going, you'll end up forming your structural ribs that intersect, and then you can start building in the notches, which we can talk about again in a separate demo. Okay, so that's a method to add thickness by doing some offsetting between surfaces. And the reason why the offset setting works is because the offset will, the top surface that was offset from the bottom one was offset in the normal direction of every point. So it's a little bit larger. So it goes off in these directions. So it's not just a straight, it's not like copying it and putting it above. It's not just a copy move. It is a new surface that was drawn, which means our normal directions are maintained to be a little more accurate, you know, when we make this thing in 3D. Another version of this, I suppose we can try, is to build on this one a little bit and use, I'm wondering if we can use these lines as section lines through two surfaces. And that will give us a very different kind of effect. Let me think here. Yeah, let's try this. I'm going to work with this one here for the sake of time. And I'm going to just select that point. I'm going to skip up 1, 2, 3 just to start drawing a diagrid, and then connect the dots from there. I'm going to do this in the 2D view for now, or not the 2D view, but the 2D framework. And let's see, I can take these now and just mirror them around. Just to get started. Let's look at that, the top view, just to give you an idea. So here's what we just drew, this sort of structure, okay? And you can keep going to fill out this, keeping the spacing. There's many different ways of drawing this. You can offset it, you can draw this from a square, but I'm going to go with this for now. Show that surface. And then what I want to do is give this an offset, kind of like what we did before. Put that on a different layer. I'm going to rebuild both of these like I did last time, just to make them a little cleaner and matching. And then what I want to do is just take these lines and project them directly upward at these surfaces. And we may run into a bit of an issue because this upper surface now projects itself outside of the boundaries of these lines. So what I'm going to do, just to be careful, is just extend these lines off arbitrarily. Okay, just to give me some more distance. To make sure that they work. And it doesn't matter how far they go so long as they go past what we think that upper surface looks like in the top view. Okay, almost there. And of course we can check this in the top view, and you can see that we should have no problems. Although I did just see that I didn't extend all the lines, so I'm going to do that one more time, making sure that they all go past. A bit tedious, but that's the way I chose to draw it. Okay, good to go. All right, so let's do a projection. So I'm going to select these and click project. The two surfaces that we want to use are these, and I'm going to go to my top view just to make sure it projects upward in the right way. That looks good. Let's look in 3D. That looks also good. We'll hide these surfaces for now. And now you can see that a little complicated to look at in 3D. There we go. So let's change our layer here and we can just take these and start lofting them. I think, nope, can't do it that way. I forgot about that. So you can select two at a time, loft them to make your structural sections. And these are going to stay, these are not going to twist because we projected them up from the 2D plane. Now, that also means that they're not going to be necessarily oriented exactly to the surface anymore, but they will approximate that surface just because they were drawn to it. So the curvature will be approximated by this, but you're no longer twisting along the surface, I guess, to draw them. That got weird. Okay, let's try that again. There we go. So again, it depends on what you're trying to build. But here's one way to start drawing out a Diagrid structure along a curved surface. Once again, I think demonstrating the importance of form first, surface first, extracting information from that surface, and then modeling the structure into it so that all the elements, the beam elements, are an accurate approximation of the curvature that you started with. Okay. That's all for this one.